To understand transdisciplinary design, we need to understand the concept of Mode 2 knowledge. Mode 1 is what you see in a traditional university department, discipline-based, academic, and often abstract. It answers questions that are interesting to other academics. Mode 2, on the other hand, is knowledge produced asterisk in the context of application asterisk. It is driven by real-world problems. It is interdisciplinary by nature and often involves non-academic partners. Transdisciplinary design is inherently Mode 2. It does not exist merely to describe the world. It exists to solve specific problems within it. If your research doesn't work in the real world, it fails the Mode 2 test. We toss around words like interdisciplinary a lot, but in design, precision matters. Let's use a food metaphor. Multidisciplinary is like a salad. You have lettuce, tomatoes, and cucumbers sitting side by side. They add to each other, but they don't change each other. A psychologist and an economist work on the same project, but write separate chapters. Interdisciplinary is like a stew. The flavors start to blend. The ingredients change each other. The economist starts using psychological concepts. Transdisciplinary is like a cake. The ingredients interact chemically to create something entirely new. You can no longer separate the flour from the eggs. Transdisciplinary research transcends boundaries to create a new framework entirely. We are aiming for the cake. So, what characterizes a transdisciplinary design? First, it is problem-focused. It starts with a real-world issue, like water scarcity or urban violence, not a gap in the academic literature. Second, it is participatory. It necessarily includes non-academic stakeholders, community members, industry leaders, policymakers, as partners, not just subjects. And third, it is recursive. In traditional research, you set your question and never change it. In transdisciplinary work, the question evolves. As you learn more from the stakeholders, you refine the question. It's an iterative loop, not a straight line. A central engine of this design is co-production. This means we don't just produce knowledge asterisk for asterisk people. We produce it asterisk with asterisk them. This involves deep stakeholder engagement across boundaries. Crucially, we involve stakeholders in the asterisk design asterisk phase. We ask them, is this the right question? Is this the right way to ask it? We don't just wait until the end to show them the report. This ensures that the research is relevant, culturally appropriate, and actionable from day one. If the community helps build the boat, they are much more likely to sail in it. Executing this requires team science. Let's be honest, collaboration is really hard. Academics are trained to be solitary geniuses. Team science provides the strategies to make collaboration work. We need mechanisms like shared mental models, so we define terms the same way. We need clear communication protocols, and most importantly, we need psychological safety, the ability to speak up without fear of being silenced. We embrace team science because complex problems exceed the cognitive capacity of any single individual. No one person can solve climate change. We need the hive mind. When designing your project, I want you to use backward design. Don't start with your favorite method. Don't say, I love surveys, so I'll do a survey. Start with the impact. What change do you want to see in the world? Then work backward. Ask, what kind of knowledge is needed to create this change? If the goal is to change a law, you might need economic data. If the goal is to change a stigma, you might need emotional narratives. Let the impact drive the method. Align your design with the scale and nature of the problem you are trying to solve. Be prepared for a non-linear process. Transdisciplinary research follows an iterative cycle. Observe, reflect, plan, act, and then observe again. It's a spiral. This requires flexibility. Real-world contexts are messy. Funding gets cut, partners change jobs, pandemics happen. Your design must be robust enough to withstand these changes without breaking. You need a design that can pivot. If your entire thesis depends on one specific access point that might disappear, your design is too fragile. Co-production introduces specific ethical complexities. We must manage power dynamics. Universities have money and prestige. Communities often don't. We have to ensure we aren't dominating the room. We must ensure non-academic partners receive credit, real credit, like authorship on papers and a share of the funding. And we must consider sustainability. What happens when the grant runs out? It is unethical to start a project, build expectations, and then vanish when the money dries up. Ethical transdisciplinary design includes a plan for long-term engagement or a responsible exit strategy. To synthesize Module 3, we have built a formidable toolbox. We have quantitative methods for breadth and scale. We have qualitative methods for depth and meaning. We have mixed methods for integration and synergy, and we have transdisciplinary design for holistic, real-world application. Our mandate is clear. We are moving beyond the petty method wars of the past. We don't care about being quant or qual. We care about solving the problem. This prepares us perfectly for Module 4, where we will dive into the nitty-gritty of analyzing and interpreting the data we collect. To summarize Lesson 3.5, we strive for Mode 2. Knowledge that works in the real world. We aim to transcend boundaries to create something new, like a cake, not just a salad. And we co-produce knowledge with stakeholders from the very beginning to ensure our work has relevance and impact. Thank you for engaging with Module 3.